All right, now we're going to begin a lesson on servos. We're going to talk about servo basics, hardware assembly, coding a mini servo. Servo basics. Servo motors take a time pulse and convert that pulse into motion control. Most have integrated gears and a shaft that can be controlled precisely. There you can see the shaft of this servo, very common servo, and when this way we connect it. And then there's the wires can give it power and give it control. How the servo operates. Servo motor internals allow for the servo shaft to be positioned at any angle, usually between 0 and 180. There are some that go 0 to 360, but in this case, most of them are 180. The servo motor is controlled by a time pulse sent by the code, which tells it when to turn. Just to give you an idea, the servo example of these time pulses is 900 microsecond puts 0, 1500, 90 degrees, 2100, 180. Not necessarily know this for a project, but keep that in mind for other projects you do down the road and some things we could do at the end of this. Hardware assembly. Okay, let's go ahead. Here's our servo. Let me point out some things on this and then take a minute to pause and build this. This is 5 volt. Here's our ground. They're going up to both here and here. So the 5 volt goes up to the yellow, So we got a positive on the 5 volt. All right, that's going up to the red servo wire here, back down to the servo. The ground is going into the screen wire, going to the brown, going to the ground of the servo. And remember, voltage is high potential, low potential, so you need a ground, you need some voltage in. And then we have the blue going to this yellow, or orange I should say, part of the servo, going in the pin 9. I also notice this is a pulse width modulation pin with that little type that tells us, as opposed to just a purely digital that only goes on and off. All right. So here we are again. There's the 5 volts we talked about before, ground here, and then pin 9. All right. Okay. These are not connected. These are separate. All right. There's no junction dot there. There's nothing to tell you, hey, those are connected. They're not. Okay, so let's get into programming it. First of all, we need to add what amounts to a library to our regular Arduino code. And this happens a lot in computer languages, is that people will build functions and then they'll create quite a collection of functions, but it might be very unique to a particular piece of hardware. And we don't want to add that to our language because if we're writing programs that don't need those functions, you're just adding unnecessary size. So with that in mind, we use libraries. And so we have pound include servo right here. Servo. And this tells our Arduino compiler to include it from another source, a source that obviously writes functions for servos. And then we're going to create a servo object, servo, my servo. Now we can refer to that as my servo the rest of the way through. This has a variable position. We're defining it 0. And so void setup, my servo attached to 9, attach the servo to pin 9. Then we have a loop, and we write it to this position. So let's talk again what we're saying. This piece of code tells the compiler to include another code, and Arduino's codes libraries build in servo code. So this is going to a library, as it were. This pops up again. We're going to refer to, we say servo, my servo. Now, from now on, we just refer to it as my servo. And in this function, which is part of the built-in functions found in this library, we got my servo attached 9. This, attaches to the servo to pin 9. And that pin 9 is a pulse width modulation pin. And that will be important. Okay. So let's go ahead this time. Let's write the code. So I want you to pause it. And we're going to, as we get ready to pause it, I should say, let me explain this code, then pause it. So we've got our library, we define our my servo, then we create this variable. We have void setup, my servo attached 9, and the my servo write the position. Remember our position up there is 45. Go ahead, write this code, try to get it work. Go ahead working it. If you want, you can try different positions as well. Okay? Now we're going to make the servo return to its original position. We're going to use this through a loop. Okay. And in our loop, let's go ahead. Make sure you save the program you just did by call it set position if you want. And this program you call return position servo. So this way you have something to remember. So we have include servo.h, servo my servo, position is 0, void setup, my servo attach 9, attach the servo to pin 9 and servo. Again, same setup we've been running. Now we have a loop and a little bit different. For position, we're going to start at 0 until position is less than 180, so 0 to 179. Increase position by 1. My servo, write to position, wait 20th of a thousandth before going to looping it through. So this slows down the loop a little bit so the servo can stay up with it. Then that will move the servo all the way up, and then you can do position 180, position greater than or equal to 1, position minus 1, and you can start moving the servo back in the other direction. All right. Good time if you want to use serial begin and record it and watch it on a serial monitor to see the position value change and watch your servo change if you'd like. Okay. Go ahead and freeze this and go ahead and begin this. All right. And if you want, play with the position of the servo now that you've got it working and change it by 5. And you can see what will happen to the servo, what happens to the speed of the servo, what happens to the accuracy of the servo. Now, let's make the servo move when we want to. All right. In this case, we're going to add, this time, a digital button. And it's just going to turn it on. Notice the 10K is actually going to right here where that red arrow is. All right. So it's going into that ground. It should be going to the hot. So it's going up here, this pin, over to this all seems to change, but here's our pin. Okay. Make sure this 10K resistor is going there. Got a pull down situation. All right. Now, when we do this one, if we just had it looping up and down, now we're just going to use a digital button to go ahead and start it up, basically. That's what this switch is going to do. So what I would like you to think about as you do this, why can't you use pin 9? Well, technically you could, but we could now use pin 8 because this is a digital. We're going to be reading pin 8 as a digital input. So we're going to use pin 9 to continue to control the servo, but we're going to use pin 8 as an input, as a button to register. So when someone touches the button, the switch, when they touch the switch, it's going to go back to pin 8, as opposed to pin 9 controls the server. So we just want you to look at this. Here's the switch. Here's the button. Here's the 10K. So it's connected to pin 8. Pin 9 is connected to the servo, and that's a PWM pin. So with that in mind, here's our code, and we're going to put this in the void loop, defining that variable digital read if button is 1. We're not going to make 1 the button. This is checking to see if it is. Then we have a container. For position 0 to 180, we're increasing by 5 degrees. This says 1, but it really should say 5 degrees right here. Bear with me. I'm going to fix this right now. I'm going to go ahead and fix this. We're going to go ahead and make that back to 1. All right. So there we go. Loading back up. So this is increasing and decreasing by 1. All right. And as long as when you press that button, it starts that loop. All right. If the button's pressed, go ahead and do the loop we just did before. So you would like to go ahead, save this one, make sure you add include button or switch with it. So remember, by now you should have 3 programs. You want to save those old programs so if something goes terribly wrong with what you're doing, you can start over again. Okay? Now, let's try controlling that servo with a potentiometer. We're going to pull the button off. We're now going to put the potentiometer right here. Okay? And I want you to go ahead and take a moment and go ahead and create this. This is actually much more useful than maybe a switch. We'd rather just use the potentiometer to control things. Okay? Now, what we're going to do here, again, the library, the include is up there, my servo, you got pot pin 0. This is going to be the pin that would connect to the potentiometer we've used in the past. And variable to read the value from the analog pin, val. And then you're going to have pot pin input, pin mode, pot pin input. All right? And you're also going to have my servo attached to 9. This attaches the pin to the servo object. Right? We've done that. And then we have a loop. Down here we're saying analog read pot pin, store to value. Value map, we're going to use the map function. A map function remaps a number from one range to another. This is a value from low, we get mapped to low, a value from off high to high. So in other words, from value from low, we get mapped to low, a value from off from high to high. So off from low, we get mapped to low, a value from off from high to high, values in between, etc. And so what this does, you can go in the help section and do it, just think about it. It takes a value, it says, okay, I'm going to use this variable. I'm going to go 0 to 1023. That's what the potentiometer reads. However, the servo goes 0 to 179. So it matches the 0 from here to here, the 1029, 1023 to 179. Okay? So it sets up a scaling for you. And then you have my servo writes whatever that value is and delays 15 seconds. So this is a great way of taking the potentiometer and controlling the servo. So go ahead and take a moment and do that. After successfully understanding code and it runs successfully, those comfortable with the controls introduced in this lesson, and you can do it manually without the Arduino library. And remember, we use those rotation reminders, 0's 900 milliseconds, 90's 1500, and 2100 microseconds. How could you get it to work without using this servo function? Remember, we got PWM here. If you can, see if you can do it without me showing you. But if you do this for a few minutes and you struggle and you would like to look at it, I do have it on the next slide. So first we would need to define the servo pin 9, right? And then we'd have pin mode, servo pin output, in which you can make this 9 and make it output. Void loop. You know, you might want to look at trying to figure this out. How did we do the LEDs? How did we control the LEDs with the PWM? Well, here's how we do it. Pulse time 2100. Digital write, servo high, delay microseconds, pulse time. In this case 2100. Digital write, servo pin low, delay 25. All right. So what we're doing is we're using digital, but we're using the pulse time as almost like a delay. All right. So we're using it much more like a delay. Okay. A little bit different in that it's not really pulse width modulation if you think about as far as turning on the servo. We're turning on high, we're turning on low, and we're using digital, but the delay here is kind of like a pulse when we do pulsing LEDs. All right. Well, that's our webinar on servos. Thank you.